Okay, so advanced GIS students, this lab one involved interpolation of table data, and you had this table data is Utah rainfall data from 2021 water year from October through September of 2020 to 2021. Remember the water years bridge annual years. And so I've added that table data as well as another set of table data, and these data are coming from a national repository where I downloaded them. The other table data is Utah averages between 1980 and 2010. So there's a 30-year period of averages. And so you're going to interpolate the water of the 2021 water year and compare that to an interpolation of the Utah normals, as well as the kind of long-term average precipitation that we get in Utah as shown by PRISM data here than in this georeferenced image that we've added on. Okay, so to add table data to your map, the best thing to do is just pull in your table, and hopefully, if we look at open up our table, we'll have some columns that have latitude and longitude, and that will work out. The issue in this 2021 water year data is that the 2020 data and the 2021 data are stacked on each other. What we want is actually for each of these stations to have all that data in one row. And so we'll have to do some table manipulation once we get it in as a feature class. So first thing we can do is right click on it, and to make it a point file, we can say display XY data and point at those longitudes and latitudes. So we right click, display XY data. We'll see very quickly that it already kind of knows what to do, and it can output a feature class, and it will do that by default, it looks like, to wherever you're working. And so that will be a permanent feature class, but make sure you save it in the right place, or alternatively you could output it, check that it worked, and then export it after the fact. So I'm going to put it within if I go back to my folders, I'm going to documents, and I'm working in lab 1. I'm going to put it here. No, I can't do that because for a feature class it needs to be inside of the geodatabase. So I'm going to put it in there, and I'm going to call it water year WY 2021 initial. And the extension I don't need to add, it will know. And longitude is the X field, so that is a horizontal, well, it's all horizontal, but it's east-west, and latitude we think of as Y. And the geographic coordinate system makes sense for our longitudes and latitudes, so that should work. We'll bring that onto the map here in a moment. And so all of those we can see are falling within the state of Utah. That worked out well. We can see that we have 631 records down here, but remember that's about divided by 2 given that they're stacked. Okay, so we're done with that 2021 table, so I'm going to remove it. And now this is a permanent file. If it wasn't, you could right click on it and export it as a new file. Now, what we're going to want to do to kind of reorganize the table is this. So we can go to select by attributes. Within that 2021 initial, we can make a new selection because we don't have anything selected yet. And we want to say, for the date, let's say that it equals 2020. And apply. Okay. So if we look back at the table, we'll probably see that every other one is selected as it should be. Whatever's selected, if we right click on it and go data export features, it's gonna export that as water year 2021. I'm gonna call it fall. So yeah, we've got that water year 2021 fall file, and we will save it and say OK. And it adds on. If we turn the one off, it really looks like the same thing, except that you see a couple are there that maybe don't quite match up. If we open up the attribute table, now has 306 selected records that are 2020. So we'll go back to the full one, and let's go select by attributes, and we'll make a new selection. We don't want the input to be the one on top, but we want the initial, and we go back to date, change it to 2021, say OK. And yeah, it should have flipped. So it was in the wrong attribute table. There's 2021. So now I right click on it again, export the features, we'll call it water year 2021, spring, summer, OK. Boom. So I'm going to turn off the initial one. So we've got these ones. We can see that they're not fully the same. Some of them aren't in both cases. So we're going to join these two tables together. And we're only going to keep the features that match. Okay, so we're going to right click. I'm going to add to the spring summer one. And to do that, we go join and relate, add join, and then we check that the table that we're joining the into is spring summer, and we don't want to join from that one. We want to join from fall, and they should have the same station name. And we don't want to keep all target features, only ones that are in both. It's giving us an issue, and it's like it's not indexed, so it make perform slow. Say OK. Now if I open up the attribute table for the spring summer, we can see that we have 2021, which is spring summer, and we have 2020, which is fall time, and Brigham City matches Brigham City, so on and so forth. We have a total of only 18 records, so something didn't work out quite well there. So let's close that. Let's go to selection, or join and relates again. Let's remove all joins. Yes. And then let's open that spring summer attribute table. So we have 325 records. Okay. I wonder if there's something wrong with using station. Maybe I'll use name. Let's do that again. So join and relates, add join. And we want to join with the fall into the spring summer. Input join field will use name. I'm not going to keep all records. Say OK. Boom. We don't have all records. Interesting. And this time we have, again, 18 selected features. Okay, so that not keep all features seems to be causing an issue. Remove join. Cancel. Remove. Okay, so we don't have anything selected. Let's go the other way. Let's join to the fall one, the spring stuff. And let's choose station. I'm going to keep all target features this time. So now I have 306 selected features. So you might play around with that. Maybe it was the order of operations. It saw some, it didn't. Maybe it was the keep all features thing. bottom line is we got the data all in a row here. And then the next thing we want to do is add a new field, because we want to add those precipitation data up. And so we're going to call it T for total underscore precip. Generally these names can't be very long. They can't have spaces. And we need to make sure it's the right type of data. So it's decimals, so it either needs to be float or double. Double is for more precision. Float is going to be fine because we're just having a couple digits before the decimal and a couple digits after. But you can see that the input data was actually in double. Not necessary, but it was. Once you've done that, you need to save your new field. Apply the changes. You can then close it. We can see that new field has shown up. It doesn't have any information. So we need to calculate it. So we right click, calculate field. And so we're putting in this table, we're calculating for the T precip, we're using a Python 3 expression type. There's a couple choices there. But essentially all that is we can use some different codes and tools. We could implement like Python code within here to calculate this, but there's some built-in functionality without doing any real coding. Where we're just trying to say it's a sum of those two precip data. So we want to have the total precip be the fall precip plus, scroll down, the spring summer precip, and we say OK. Okay. Now, certain rows are null due to an error while doing the expression. So those null ones are probably ones that didn't have data in both areas. So we might say that we don't want to do those ones in our interpolation. So we could sort this ascending and probably see the nulls at the top, which is quite a few actually. Okay, so I'm going to collect all those nulls. I'm going to shift those, and I'm going to delete those rows. Okay, that was not a good move because the tables were temporary and a bunch more things went null. So let's back up. Undelete that. So did we? Yeah, okay. So we don't want to delete it after all, I guess. That is a bad move. Because somehow it triggered, because the table joining is temporary always. And we found this issue a lot. So the join table is not going to be permanent. If we sort descending, the precip values that we calculated will become permanent as we save this to a new file. These other ones will not. If we wanted them to become so, we could make new fields. So we could add another field, and we could call it fall, or some spring 21 precip, and can make it a float and say save. Oh, didn't like something. Did it correct itself? No, I don't think it likes the name is too long. So we gotta go back to add a field, and we gotta get that name shorter, so we say some spring underscore P. And we call it float. I think it'll work now. No. Save. No. Don't like that. So let's call it something else. Okay, so precip underscore 20. Oh, the table is being edited. Okay. It's not going to let us do this at the moment because I went and pressed delete before and it's not happy. So if we go back to edit and we say discard the edits. So now add field, summer, spring, PCP, float, can't forget that, save. It's now happy because I was not still editing it. Okay, so there it is, and this one we just actually want to make sure that we have the precip from 2021 filling it so that we know where it came from when the rest of this stuff goes away. So I'll calculate the field and just simply say that that value is equal to this other spring summer precip and say okay. Oh, it's not happy, is it? What happened there? It didn't work. Let's try again. I'm going to do that times 1. I think maybe me calling it a float rather than a double made an issue, but I think that's going to be solved by this. No. Certain rows are set to null while evaluating the Python slash an unsupported operation for the non-type and int. Something was an integer? I don't believe that's true. Yeah, so it's got an issue with the type of data it's calculating. So let's go back and look at the fields again. So if we click add, we can see them. So there's float, and the other one's double. There's no integers involved. Should be okay. Can't edit it after the fact. We don't want a new field. So I'm just going to close this. And I don't want to save any changes. Calculate field. So, So fall, spring, summer precip equals the other spring, summer precip is what I want it to be. But it's not happening for some reason. So I think if I say float around the outside of this, it might become happy. Not the non-type. Okay. Yeah, it's not pleased. Let's delete that field. Okay, so let's try one more time. We'll add the field, and I'm gonna make sure it is a double like the other one this time. I'll just call it precip 21. Save. Close. Calculate field. Precip 21 equals this other precip. It gave me a ton of nulls again. That's not good. Yeah, so I guess it's just not gonna behave for me. So I'm gonna go ahead and delete that. And at this point, you know, I can get the precip from that part of the year by simply subtracting it from the other one. So I'm going to do 94 minus 40 equals the fall precip if I wanted that to be there once this other part goes away, which is going to happen when I do this. So if I go data, export features, and call it water year 2021 final. Okay. Turn these other ones off. We can see we have less total numbers. Interestingly, seems like a little too few. Oh, not all are selected. Oh, that was the issue. Some were selected, and that's why there was an issue, probably. Okay, so let's clear. Okay. Open attribute table of the final. Only have 49 that exported. So that is not appropriate. So we actually don't want that. Remove. Go back to the fall one, which has all of this. It's 306. We want to have all of those exporting. That should be the case. Data export from fall, and we call it water year 2021 final 2. Okay. Okay, that's looking better. I must have had something selected before, so now if I open this attribute table, I should have 306 records. And now we have a bunch of nulls, but you can see the T precip is there. So we can actually edit this one because these nulls are not helpful. Delete. Yes. The table joins are not permanent. It's an important thing to remember. Okay, so there's our T precip. That's going to help us out. We can do our interpolations off of that. Interpolation, other than the tin, are going to, okay, interpolation. It's got to spell that right. Those are going to be found primarily in spatial analyst tools, but you might find them redundant in 3D analyst. So I'm going to click on spatial analyst tools. You can see that in the interpolation window is here. And so you can do those interpolations. And if we have an area of Utah shape, then we can constrain it to that. It can be helpful to get the geometries we want of that interpolation for the state of Utah. It's not going to work for every one. In the case of tin, it has to go through the actual points, and it is confined to a triangulated network of kind of geometry. But yeah, you should be able to move on to your interpolations from there. But the other thing we need to do is correct that Utah normals table. So to do that, just go ahead and join this table we just made, or that feature class we just made, to so that's water year 2021 to the Utah normals, and we would join by name or station, and go ahead and do that. So now if we open up the table, we can see a whole nother set of information, including total precip, and on the left, annual normal precip. This is a temporary thing, but the good news is we can display XY data from the temporary. So we want to go on to the final two, longitude and latitude for the Y, and go ahead and say OK. So now that shows up. I'm going to change the color so we can see them, and we should see that they're not, not everywhere the other stations are. Not every station has a 30-year record. Okay, so that's great. That's all there. It seems like, and maybe even permanent, given that it traveled with it, which is somewhat surprising. We don't need this latitude or longitude, so I'm gonna what I'm going to do is this. I'm going to export that feature to one that's, I'm going to call it more permanent. So Utah average precip. Average precip. I'm going to remove the one I made before. I'm going to open the table of this one. We may see now it carried everything through. Didn't delete it. That's pretty handy. There are some null values, so if you wanted to sort ascending and things like that and delete those null values, you could. Some of them aren't even showing up because of that. So in that case, we could select those and delete those rows. Didn't actually delete them. Interesting. I'm going to back up. Didn't like how that behaved. So instead, I'm going to invert my selection, or I'm going to rather select by attributes within Utah average precipitation, and I'm going to say where I'm going to say new selection, where the second longitude is equal to null. Well, it's not happy with that. Oh, is null, sorry. So where longitude is null, apply. Okay. Invert the where clause. Actually, let's get the stuff that's not null and say okay. So go down, those things are not null. Let's export those features as Utah average precip final. Remove that one. Check out this one's attribute table. Now we should have data for the most part, but we can see that some of the precips are null. So we might it just won't evaluate those in the interpolation, which is fine, or you could go through and clean it more. If you didn't want to have these other latitude, longitude information, you could delete that too, but you can move forward from here to do your interpolations. Yeah, so anyways, I hope this helps you with editing your tables. You can see that it can be a little frustrating sometimes. It's not really clear in some instances to me why joins do carry through or don't, given that we were able to carry through the join here. I guess because that join was originating from within a within a feature to a table. It could be partially that, so maybe that allowed it to be more permanent. But it didn't work in some cases. You notice that. All right, well, this is a good stopping point.